La Nina is in the ocean, but will it build into the atmosphere? I am Mark Sponsor, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, September 21st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write up down below. We'd be happy to answer. And if you would like to make a contribution to the cause, you may hit the super thanks button down below, the heart with the $ sign in it. With that, I'd like to thank the folks that donated last week. Kim in California, Tim Caston, Coach Nate, Surf Waxed, E-Slate, Starcotic, Clay Goose, B. Nadine, and finally, Evolution Moto. Quite a cast of contributors. Actually, it was 2 weeks ago. I really appreciate it. Thank you so much. With that, let's get to work. We'll start by looking at significant wave heights around the planet. Start in the North Pacific, a little bit of a low-pressure system generating 15-foot seas in the northeastern Gulf of Alaska, not really doing a whole lot. A pair of tropical systems in the far western North Pacific. One of them maybe has some potential. We'll get into that in a little bit. In the South Pacific, 2 gales with 24-foot seas or so, but things definitely winding down in this region. North Atlantic, Hurricane Gabrielle off the coast of Florida, actually generating some swell radiating towards the coast. Expected in, I believe it's tomorrow and a couple of days after that. A little bit of activity off of Europe here, but nothing particularly strong. In the South Atlantic, a gale with 26-foot seas may be offering some hope for South Africa. And really the winner at this point in time is, again, the Indian Ocean. Seas 44 feet here in this gale. Whether they're aimed up at any of our major targets, probably not, but you can see there's already a developing swell front pushing north, so some swell likely for that area. All right, let's dig a little deeper. But first off, we'll take a look at current conditions. We're going to start up in the Pacific Northwest, Grays Harbor buoy. We're looking at the buoys, number 036. This is off the Oregon-Washington border. We're looking at all the energy that's hitting that buoy, all the way up from 33.3 second period energy, which there is 0.0 feet of, so not a whole lot going on there, all the way down to pure like wind chop, 5 second period wind swell. We see a bump of energy here in about the 9-10 second period range, bunch of readings in the 2.5 foot range, so it looks like wind swell there. The algorithm puts it all together, primary swell 5.4 feet at 10.2 seconds, from 279 degrees, making surf at 5.5 feet, and I did get a confirmed report today of surf in the head high to slightly over head range and pretty consistent and pretty pounding, so there is rideable wind swell up in the northwest. Oh, and secondary swell 4 feet at 6.7 seconds from 269 degrees. That's just merging in. You can see it right here. It's all just part of the same wind swell. And we're really trying to be super conservative here and not overstate anything, but you get the general idea. Then down to Northern California, and good news to report. The Point Reyes buoy 029 is back up and online. This is just north of Ocean Beach there, off of Point Reyes in deeper water. Looking here, we see a little bit of energy in the 11 second period range, and then some wind swell in the 5 to 6 second range. Let's see how the algorithm does. Primary swell 3.1 feet at 12 seconds from 280 degrees, making surf 3.7 feet. That's about like what it, and that might even be overstating a little bit. And then the wind swell 5.6 feet at 5.8 seconds from 320 degrees, making surf at 3.3 feet. So waist to chest high, pretty warbled this morning. Maybe it's cleaned up a bit by this afternoon. Down to Southern California, the Point Loma South buoy 191 off of San Diego. Since it is pretty well protected from northwest wind swell, we don't see a whole lot going on. Maybe just some background southern hemi swell energy. 1.3 feet at 13.5 seconds from 205 degrees. That makes surf at about 1.8 feet. And then secondary swell, 1.1 feet at 10 seconds from 243. It's probably more from 290, but only 1 foot of surf. So pretty quiet down south. Over to the south shore of the Hawaiian Islands, we're using the Lanai buoy number 239. There is a little bump of southern hemi swell energy showing up here on the spectral analysis. Let's see how that pulls out. Primary swell 2 feet at 12.8 seconds from 197 degrees, making surf 2.5 feet. And then some wind swell, 0.9 feet at 9.5 seconds from 204 degrees. And pretty much indistinguishable. But there is surf, in the waist to chest, maybe top spots, maybe shoulder high or a little bit more. So there is some southern hemi swell still pushing into the south shore of the Hawaiian Islands. And then finally, the north shore of the Hawaiian Islands, the Waimea Bay buoy, number 106. Again, we see mainly wind swell here, nothing too significant. Primary swell 4 feet at 7.9 seconds from 37 degrees, making surf 3.1 feet, and then some other energy, 1.5 feet at 11 seconds from 337 degrees, making surf at about 1.7 feet. And yeah, there's waves, waist high, maybe a little bit more on exposed breaks in the North Shore, but nothing very strong or lined up or powerful or anything like that. All right, so what's been going on in the past week? We didn't do a video last week. I was out of town, but we can go do a quick review of what's going on. We're starting on Sunday, September 14th. North Pacific, a little bit of low pressure in the Gulf, not generating meaningful seas. Same deal off the Kuril Islands. Put this into motion. Yeah, you see there's a little bit, what is that about? 16-foot seas, something like that. That was on Monday, and nothing over in the west. Now, there was some fetch here, 20-foot seas or so, but all north of the Aleutian Islands doing nothing for swell production. Another little system right up pushing into North British Columbia, developed on Wednesday, really nothing there. And then we're getting into the current setup with, I'll call that 16-foot seas, targeting the U.S. West Coast. That was on Saturday. I think swell energy from that is actually what's hitting the Oregon area now as we talk. And the two tropical systems, again, I'm holding off on this. When we get into the forecast, we'll talk about them and all their stats, that sort of thing. But really, there maybe is a little bit of hope of this one here, providing some background swell for the Hawaiian Islands, but that's even a bit of a reach. Now, last Sunday, the 14th of September, in the South Pacific, here's New Zealand. A gale did develop with 27.9-foot seas right here, the highest seas over this entire domain. That is, I believe, what has produced the swell that is hitting Hawaii, South Shore as we speak. Nothing huge, but rideable surf nonetheless. You see the gale quickly dissolved. In fact, we can actually go back a little bit further. Yeah, that was pretty much the peak of it right there a week ago on 12Z Sunday. So that was all of that. Then going forward, we're looking for anything like 27-foot seas or higher aimed off to the north. We're already into Friday, not seeing it. So that would be like some dark shade of red here. We're into Sunday, current time, and that's Saturday. Here we go. One more series of frames. There's Sunday. So really, after the swell is hitting the South Shore, it looks like it's over, and I don't even think that swell is going to do anything for California. At best, minimal background swell energy from since the storm's up here, 218, 220 degrees, something like that, but probably not particularly noticeable. To the North Atlantic, a week ago, there was a gale with 22.1-foot seas right there off of Ireland on Sunday. That system actually pushed on land into Monday a week ago. See another system set up on Wednesday with 29-foot seas. There was pretty blustery conditions in the Ireland, Scotland area on Wednesday into Thursday associated with that and rain. That pushed through. The beginnings of Gabrielle set up as we get into Friday, approaching, tracking north of the Windward Islands, and let's see, we're into Saturday. You see the general ID, and here we are Sunday. Gabrielle finally starting to look somewhat reasonable well east of Florida, probably more generating swell targeting up in this area. Fetch, the swell, low pressure, winds move counterclockwise around the low. The low's moving this way, so that always sets up the northeast quadrant of the storm to be the most productive in terms of swell potential. You see if the core, this is already in the, we'll say, Cocoa Beach area. That's probably the beginning where decent swell would hit more of it up into the northeast and middle Atlantic type regions. Then down to the South Atlantic, putting this in motion, again, reviewing what happened over the past week. On Monday into Tuesday, 28, 29-foot seas off South Africa, quickly build up into the 39-foot range. Did it get higher than that? Sure enough, there we went to 44 feet on Wednesday, the 17th of September, and then out of the picture. Most of that, I don't know how much of it actually hit South Africa. It really seems like it was more focused to the northeast, so Bali in that area, as usual, would probably do well. Another little gale tried to organize on Saturday and Sunday, but it's falling southeast. Had, like 26-foot seas. And there we are, current frame, 27-foot seas, pretty much aimed southeast. I don't know how much South Africa is really going to get from that. And then finally, off to the Indian Ocean. Again, we're looking at what happened over the past week. We know something blew up or developed over here. There you go. There's your high seas, 44 feet. That pretty much faded as we got into Friday, but a swell front you can see is already developing. That energy pushing northeast. Now, that's a good long ways away from Indonesia and Western Australia. Another gale started developing on Saturday. Here's yet another one, 39-foot seas, but that's all aimed southeast, so don't know how much is going to result from that. And so you can see still a reasonable pattern focused on the Indian Ocean, probably more so than any other place on the planet, and still in the southern hemi, and we're almost at the end of September. Right, so let's look forward. We're going to refocus now from the southern hemi because for the most part it's going to sleep. We're going to focus on the North Pacific. We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, they help direct their track. We're looking for a trough, a push in the jet to the south. You see it right here. So let's get ourselves oriented. Mexico there, California there, Japan buried under here, the Kuril Islands, the Kamchatka up here, Aleutian Islands here. So the jet stream actually looks reasonably decent, consolidated, winds more or less running east on about the 45 to 48 degree north latitude line. We have a bit of a trough here. When you get a dip in the jet to the south, that helps create a counterclockwise flow aloft. And also down at the ocean surface, that's the hallmark of low pressure. And if low pressure, if it's strong enough, generates winds, those winds get traction on the ocean surface, actually imparting energy to the ocean, creating seas. Those seas, as they radiate away from the fetch area, the lesser period elements decay away, exposing longer period swell energy. And of course, swell when it hits your beach turns into surf. That's exactly what we're looking for. But it all starts with the trough. So we have a little trough here in the, I'll call it the northwestern Gulf of Alaska, but otherwise, no clear support for gale development. You see the trough digging deeper as we get into Monday. There, that would be your counterclockwise circulation there, offering some hope, but then quickly pinching off. That is, the trough gets too tight to really support gale formation. So I'm not sure how much we're going to see from that one. But then as we get into Wednesday, another trough and winds building in the jet to about 180 knots. Another trough in the Gulf, and then digging out even deeper. There you go. That looks a little bit more like a legit trough as we get into Thursday and Friday. Notice also a cutoff trough and secondary energy pushing into Southern California on Friday. The trough actually digs out. Hawaii's right here. What is that? 1, 2, and I'll say 700 miles north of the Hawaiian Islands, falling to about the 600-mile north range. So that's kind of more of a backdoor trough than a legit trough, but still, it might support gale formation, produce surf for the Hawaiian Islands. It gets cut off, though, from the main jet stream flow, and the main jet stream flow 1 sort of splits off, gets fragmented, not looking particularly great. this does not look like a good late, early season pattern for the North Pacific. Kind of looks like a La Nina type pattern. We'll get more into that in a minute. But it takes winds blowing on the ocean surface, not up at the jet stream level, on the ocean surface, to produce surf. All right, so just doing a quick scan here. We don't see anything in the Northeast Pacific. We're really looking for 40-knot winds or stronger. We have a little bit of a low-pressure system here over the Kuril Islands, not doing much, but mainly it's two tropical systems. This one here, Regasa, I guess is how you say it. Right now, winds are 145 knots, so that's an extremely or very strong storm. I think it's Cat 5. Forecast to push just north of the Philippines and further inland, not reaching land till nearly Vietnam, and by then the thing will be all played out. No recurvature forecast. Now, Naguri, that is this system, which is, 500 miles southeast of central Japan. This forecast, right now it's pushing northwest, but it's starting to make the turn to the north and then northeast in the next day or so by Monday night. Slowly fading. Winds are 120 knots they were this morning. It'll be down to 100 knots, so that's like 115 miles an hour as we get into Monday before this system kind of peters out. Hawaii, right here, the Great Circle Path from here to here is about 292 degrees, which relative to the north shore of Oahu is for the most part shadowed by Kauai, but it is possible there could be some little background swell pushing into the Hawaiian Islands. I don't know, what'd that be, like maybe 4 days out, something like that. So something to keep your eyes on. All right, let's put this into motion, see what we got. There, you can see the turn to the northeast. That's really what I'm watching. Sort of sits there and percolates into even almost Tuesday. Now, we'll go back. We'll watch the tropical system, and then it just sits here and circulates around, can't quite make up its mind. Now, this is a different pattern. Oh, this is the 18Z run of the model. I saw the 06Z and the 12Z. This is actually more favorable, so that is kind of a good thing. Now, my bigger interest was this system here that's forecast on Tuesday, developing over the North Dateline region, mainly pushing north of the Aleutians, but then is forecast to start dropping down south over the northwestern Gulf of Alaska on Wednesday. Only 35-knot winds with a little bit of secondary energy behind that. So I'll have to take a look at the wave models and see if anything comes from that. Also notice some sort of a tropical system forecast circulating here south of Southern California. Again, there's nothing on the charts right now. It's supposed to develop. So we'll see if this really plays out. You see this kind of gentle northwest track. That would be good. Oh, and then finally, forgot that right here. The cutoff trough north of the Hawaiian Islands on Saturday. Winds supposed to build to 40 knots, aimed due south at the Hawaiian Islands. And I see. We're toggling between the 12Z and the 18Z run of the model. So the new model's just starting to push in. And so we'll have to see how that develops. But that's like a week out. So odds of it happening at this early date are probably pretty low. What are the effects of those winds on the ocean surface? All right, so we're going to start here in the North Pacific. Again, our two tropical systems. This one, Naguri, is the one we're watching. This is the 12Z run here, so we'll have to see. There's the turn to the northeast. Again, this is a very small system, sort of percolating along there, and then you see it just starts petering out on Tuesday night. Now, this is supposed to rebuild, but you see all the fetch is pushing up into this way, so this rebuilt doesn't do anything. And then we'll focus on that system. It fades out. Now, in the meantime, let's go over to the North Dateline region on Tuesday. Here's our gale, 22, 23-foot seas. And then building with 20, 22, 25-foot seas aimed at the Pacific Northwest, maybe down into California. Capable of producing some, I'll give it 13, 14-second period swell with luck. And that fades off. Here's another tropical system there on Friday. Forecast developing, and then probably of more interest is the cutoff low north of Hawaii with, it was about 26-foot seas, but quickly fading out. So some marginal bit of hope for both Hawaii from a system north of it and a tropical system, maybe something for California and certainly the Pacific Northwest from the gale forecast up here. And I'm just discounting this tropical system completely for now. To the southern hemi, South Pacific, we'll put this in motion. The reality is I'm not seeing a whole lot of anything on the charts. Again, we're looking for 28-foot seas or better. Barely 30-foot seas, and as soon as it hit the far southwest Pacific, it just died. And where are we? We're already into Saturday. There is 20, 22, 24, 26-foot seas. Nope, and nothing. So it honestly looks like the southern hemi has pretty much gone to sleep relative to the Pacific Ocean. To the North Atlantic, Gabrielle sitting off of Florida, lifting north, spraying swell probably from here up into here. Nothing huge. I mean, it's not a particularly strong system, and then it starts racing off to the east. Of more interest, now, sure, certainly for Europe, that's been the pattern. Jetstream just driving everything into Europe. But another tropical system is forecast north of Haiti, forming on Thursday, trying to build. You see it right here. That's probably, about 20-foot seas on late Friday, the 26th of September, off of West Palm Beach and much closer to the coast, about 300 miles off there, and building with seas in the 27-foot range, and then probably up into the, it says 35 feet. Yep, that's right. Right off of the Outer Banks, so swell, probably pretty raw, pretty big, and then maybe grazing Cape Cod, but for the most part, according to the models, staying off the coast of the entire U.S. East Coast. That's a good thing. But swell likely being produced if this system even forms. To the South Atlantic, here we are, current time. We'll just put this into motion. Well, there's a gale, 26-foot seas, but all aimed due south, so no hope of anything from that. You can see it almost seems like there's just high pressure here in the jet, just driving everything in this direction, then sweeping up into the Indian Ocean. There you go, sure enough, 33-foot seas. Most of this probably bypassing South Africa, maybe some sideband swell. What was that? Right about there. That looks like the peak of it. 37-foot seas south of Madagascar. And where are we? We're at, here we are, approaching Sunday, and things fading out. Seems like the South Atlantic pretty much done for the season. But the Indian Ocean's still doing pretty well. Put this into motion. We know there's something going to organize over here. There it goes. Lifting northeast, 38, 38-foot seas here relative to Australia. Two of them at the same time. Looking pretty good for South Australia, but I'm really looking at Bali and Western Australia. Seas building there. Over a broad area, 37-foot seas lifting northeast. That looks like a decent swell producer. You can already see the swell front just pushing off to the northeast. We're out 180 hours, so something to keep your eye on there. Local wind forecast for the California area in Hawaii. So California here, this would be Southern California. There's Point Conception, Monterey Bay there, San Francisco, so Central California, Northern California, north of San Francisco area. Hawaiian Islands out here, high pressure in control, but pretty weak. A light northwest wind flow for the California coast north of Point Conception. Trades 15 knots for the Hawaiian Islands today. As we get into Monday, a little bit of a gradient tries to develop off of Cape Mendocino, 20-knot north winds, maybe generating some wind swell. The exposed breaks for Central California. Trades pretty light for the Hawaiian Islands, 10 to 15 knots. Tuesday, the gradient fades out, a light wind regime for California. Trades 10 knots or so for the Hawaiian Islands. Wednesday, same sort of deal. Northeast winds, 10 knots or so, maybe 15 for the Hawaiian Islands. Light wind regime for California. Thursday, same sort of thing. Winds limited to Cape Mendocino. I mean, this is pretty typical for this time of year. Gradient limited north of this area. Light wind regime for most of Central and actually most of North California. Here comes the beginnings of the cutoff low relative to Hawaii. Oops, not that one. There's another one forecast. Oh, look at this. This is a new update Friday. 25 knot north winds for North California. So wind swell on Friday, the 26th of September. There's your tropical system. 132 hours out. Looks good. We'll see whether it really happens. Here's the cutoff low now. Developing 40 knot north winds targeting the Hawaiian Islands. But locally, it's hard to tell. Maybe some sort of a light north wind flow. That'd be on Saturday. We'll go out to Sunday. And here's your low, 35 knot winds. Winds pretty light for the Hawaiian Islands. Light wind regime for California. Tropical system here. Have to keep our eyes on that. And though no significant cold front generated wind or snow is forecast yet, since we're getting close to the season, let's take a look at rainfall potential for California. I'm sort of doing this because I know some of our viewers have been commenting about the monsoon rain in Southern California, and another bout of that is forecast. There you go, right there on Tuesday night. That'd be Tuesday the 23rd into Wednesday. And it mainly looks like this would be like from Orange County northward, even into central California. And then fading Wednesday night, maybe rain developing in the Sierra. But relative to north and for the most part central California, you see high pressure in control and no meaningful precipitation forecast. The backpackers temperature forecast for the Sierra. The intersection of the Pacific Crest Trail and Tioga Pass Road in Yosemite, right here where those two roads intersect or trails intersect, 8,700 feet. You can see, and we actually have data from this morning, so temperatures today on Sunday, 45 degrees sort of thing, maybe 50 degrees. And that pattern sort of holding, maybe temperatures getting up to 60 degrees on Tuesday. Maybe a little dip here on Thursday down to, 45 degrees, something like that. But mainly just hovering in about, this would be mainly highs in about the 50-degree range for the coming 8 to 9 days. And then maybe a cool off 10 days out, but I don't believe that. So surf spot forecast for a couple locations. To start up north, Pacific Northwest, Columbia River area. Surf heights, well, like it was today in the 5 foot, maybe 6 foot range. This would be wind swell. That holding into Monday, then slowly trickling down. But this steady background Gulf of Alaska wind swell continues, finally dropping out on Friday, only to be replaced with yet more swell as we get into Saturday and Sunday in about the 8 foot range. Winds actually looking sort of a mix of offshore, early morning to northwest at 10 knots in the afternoon, so not a bad pattern at all. Swell heights, 5 feet at 11 seconds, 4.5 feet at 10 seconds, dropping off. Then the new swell comes in, theoretically, 5.9 feet at 14 seconds. So this actually looks like a legitimate fall-type swell. And down to Ocean Beach, San Francisco, mainly wind swell. You can see it here. 5 feet or something like that, and that's probably on the high side because a lot of this is going to be shadowed by the Farallon Islands. On Tuesday, trickling down, then back up Friday, Saturday, a mixture of energy coming from the Gulf of Alaska and locally generated wind swell. Let's see how we do here. Swell heights 5 feet at 10 seconds is your background Gulf swell, going to about 3.5 feet at 10 seconds. Then up to 6 feet at 9.5 seconds. Then here's that swell that was much larger up in the Pacific Northwest, maybe showing up on Sunday, 3.5 feet at 13 seconds. So maybe some rideable surf a week out. By rideable, what I meant was like real swell, 13-second periods or more. Wind swell, that's okay too, plenty of that. Right, down to San Diego. Totally protected, no significant swells coming from the south or the north, and the sea heights reflect that. Something, surf heights in the 5.4 feet maybe on Sunday. See where that's all coming from. Swell heights, 1.1 feet at 11 seconds. So a little background swell. Here we go. The same swell that's hitting Hawaii today, probably hitting Southern California, 1.5 feet at 14 seconds. Not a whole lot. And then that other swell, 3.94 feet at 13 seconds. Oh, that's from the south. You know what that is? That's swell from that hurricane. If it forms, I mean, the models just are, assume it's going to happen because they say it's going to happen. And so you get these big numbers. Will it really happen in reality? Right now, I'd say probably not. North shore of Oahu, surf heights 2 feet, 1 foot. Building a little bit the 4 foot range. What's that on Friday? But I think here it shows 8 feet. My guess is this is on Sunday. This is the swell from the cutoff low that's forecast north of the Hawaiian Islands. Let's go take a look down here. Yeah, swell heights 2 feet at 13 seconds, 1.2 feet at 10 seconds. Oh, local wind swell here, 5 feet at 9 seconds sort of thing. And then here we go, 6.9 feet at 11.6 seconds on the very tail end of the model here. Don't believe that's going to happen, but at least it's something to look forward to. Then over to Jefferies Bay, still looking since the southern hemi is reasonably active. Nothing really happening, 17 feet or 1 foot. My guess is it's probably all wind swell. You see winds 42 knots out of the west. That's probably not rideable. Then we get into a more reasonable regime here. Surf heights in the 12-foot range, fading to 8 feet as we get into Friday. Then back up to 14 feet on Saturday and Sunday. That's off the coast, something far less for Jefferies Bay, but still potentially surf. Oh, and swell heights. Let's take a look here. 16 feet at 10 seconds. There you go. Sure. 6 feet at 8 seconds. Yeah, just kind of a mess. Then it settles into the 10-foot range at 11 seconds. 7.5 feet at 12 to 13 seconds. And then 9 feet at 14 seconds. So probably later in the week is the better bet. And finally, Bali, surf heights in the 10-foot range, fading to 8 feet, 7 feet, 8 feet, then dropping out as we get into Monday. See what the swell heights are. 6 feet at 14 seconds, 5.5 feet at 14 seconds, 5 feet at 15 to 14, 5.5 at 14. So this is all legitimate swell the entirety of the week. Some of it probably coming from a pretty good long distance, probably a long wait between sets, but nevertheless, real swell. All right, let's go take a look long term. Let's look at examine the two major weather oscillations that affect the production of surf in the window looking 2 to 3 weeks out or more. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start by examining the MJO, the Madden-Julian Oscillation. There are two phases, the active and the inactive phase. The active phase is on one side of the planet and the inactive phase on the other. They rotate around the planet west to east on the equator like that. Okay, the active phase is our friend. It's a low-pressure system. It takes warm, moist air at the ocean's surface, lifts it aloft. That warm, moist air gets absorbed by the jet stream, making the jet stream stronger, and a stronger jet stream is better at digging out troughs, which support storm and gale development. The inactive phase of the MJO is like a high-pressure system. It creates falling air that cuts off the flow of moisture to the jet stream. The jet stream then is weak and doesn't support gale production. We're looking at data from the TAO buoy array, a series of buoys strung across the equator. East Pacific here, West Pacific here. That is the equator right there. There's New Guinea there. Dateline right there. These arrows are the TAA buoys are used to monitor El Nino or La Nina, but they have wind sensors on them, and we can use the wind sensors, their 5-day average winds, to get a sense of what's going on with the trades. Why does that matter? Well, the active phase of the MJO being a low-pressure system and trades being generated by high pressure, if trades are weaker than normal, that is typically driven by the active phase of the MJO. The low pressure of the active phase of the MJO sort of chops out the high pressure, the standard high pressure that produces trade winds. Conversely, the inactive phase of the MJO, it being a high pressure and trades being generated by high pressure, sort of marry together, making trades stronger than normal. So by examining the trades, you can kind of get a sense of, well, are we in the inactive or the active phase over certain regions of the Pacific? Again, East Pacific here, West Pacific here. Trades blowing, just looking at the length of the arrows, blowing pretty hard over the East Pacific, pretty hard over the Central Pacific. There's the date line right there, and pretty hard over the West Pacific. but it is not the actual wind speeds. It is the difference from normal for this time of year. So we can look here in the East Pacific and we see trades. I don't even see any arrows, so they're pretty much dead neutral. Same thing over the Central Pacific. Get into the West Pacific, they're blowing a little bit harder than normal. So probably inactive phase here and maybe a neutral MJO over this region. Let's go look at the forecast. The model and confirmed data, 850 millibar zonal wind anomalies. Basically, that's just saying, are the trades blowing harder than normal? That would be the blues, easterly anomalies, or weaker than normal. That would be the oranges and the reds. That'd be westerly anomalies. But this is over the entire planet. This is what has happened right here. That's the forecast for the next 2 weeks. So the date line runs right up the middle of the chart. This is the chart for the entire planet. West Pacific starts about 125 east, so from there to about 170 west. Call it the Kelvin wave generation area. That's the really important part, where if you have westerly anomalies over the Equatorial West Pacific, that takes that warm moist air, lifting it aloft over the West Pacific. The jet stream is coming from the west, moving east over top of that. There we go, like that. And what that does is it strengthens the jet stream as it makes its trek across the Pacific, theoretically helping to produce storm production. But what we need is westerly anomalies in the West Pacific. So today, 21st of September, there is 150 east. There's the date line right there. So we have a little bit of westerly anomalies. They've been there for what, a day or two? And about 3 or 4 days from now, they're supposed to start collapsing. So I don't know that this certainly doesn't look like an active phase of the MJO. It's just sort of a little burst of westerly winds, but nothing significant. You can sort of see the pattern just looking. It's been easterly anomalies, and here's the forecast. Easterly anomalies filling the entirety of the Atlantic basin for the next 2 weeks. That suggests the inactive phase of the MJO, or at least a neutral MJO. Next up, outgoing long wave radiation forecast. What's that mean? Sounds like a mouthful. It's just, are there more clouds than normal or less clouds than normal? Why does that matter? Well, if you have the active phase of the MJO and it's taking warm moist air and lifting it aloft, eventually that warm moist air, when it gets up into the 20, 30,000 foot range, it's going to hit cold air, it's going to condense and start making clouds. Conversely, the inactive phase of the MJO is producing falling air, no moisture, so you'd have clear skies. So that's all this model is trying to say. Clear skies or extra clear skies compared to normal would be like the orange here. These cloudier skies would be the blue. And let's get oriented. South America, Central America, Hawaii, New Guinea, PQ. That is the equator, the date line right there. So this is the area that we're really interested in. Looks like a dead neutral pattern today. This is the statistic model going out 5 days, 10 days, 2 weeks from now, 15 days from now. It looks like extra clear skies, the inactive phase of the MJO setting up. The GFS model, or GEFS, the ensemble version, basically saying the same thing, but starting 10 days out. So inactive phase of the MJO starting 10 days from now. Phase diagrams for the same two models. Statistic here, dynamic here. How do you read this chart? The heavy dot is where the active phase is. The MJO moves from west to east, from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States. Remember, it's down on the equator. Over the Atlantic, to Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is, so say roughly in the East Pacific. And the further the dot is outside of the circle, the stronger it is. Well, the dot's right in the circle, so an extremely weak active phase in the East Pacific, and 1, 2, 3 forecast tracks have it just noodling around, basically doing nothing. This per the statistic model. So an extremely weak active phase of no real meaning for the next 2 weeks. Dynamic model puts the active phase moving into the far west Indian Ocean 2 weeks from now. And again, inside the circle of death, and extremely weak. So no real support from the MJO. And this has been the problem all year. The MJO, well, I shouldn't say all year, but since, maybe April or something like it. It's just been like non-existent. The models keep saying it's going to happen. The active phase is going to come, and it doesn't. I've given up on the models. We're just like in the MJO just doesn't exist right now for whatever reason. It's extremely weak, and that seems to be going to be the case, at least for the next couple of weeks. So let's go look at the CFS model. It's a dynamic model. It goes out 1 month. Past performance is here. Forecast here goes out 1 month again. This is the whole planet on one chart, the date line running right up the middle. Far west Pacific starts about 125 east, so over here. The blues are easterly anomalies, roughly the inactive phase. The oranges and reds, westerly anomalies, the active phase, MJO, dark line. So a solid line is the active phase, a dotted line is the inactive phase. So the West Pacific right in this area right here, you see today, here's our westerly anomalies, that little 2 or 3 day bump of westerly anomalies driven by, what's the red line here? Equatorial Rossby wave. So it isn't even MJO related. It's just some transitory sort of thing. Westerly anomalies holding for a couple of days and then collapsing. Easterly anomalies taking over. Though you notice here in the far West Pacific, kind of a neutral weak west wind pattern forecast into almost mid-October, but then inactive phase of the MJO setting up. So this is probably as good as we're going to be for the next 1, 2, 3 weeks, and then after that it even gets worse. And then the CFS model going out 3 months. Past performance down at the bottom, the forecast is here at the top. Date line runs right up the middle there. Far West Pacific starts about 125 east, so right about here. So we had been talking about this forecast building of westerly anomalies in the West Pacific. In this model, I think the problem with all the models is because the MJO and just the lack of complete momentum in the atmosphere, the models just are having a really hard time trying to figure out what's going on. The model says westerly anomalies in the West Pacific today for about a week, maybe holding for 2 or 3 weeks, and then turning easterly. And then as we get later into October, active phase of the MJO setting up. But we haven't had a legitimate active phase of the MJO, and well, you see there's weak little bits of something here, even in June and July, but really nothing of any significance. In fact, let's overlay the MJO here. Here you go. These like one in the red contours are the active phase of the MJO. So here we are, inactive phase kind of right now. Here is a weak active phase, another inactive phase, and the model isn't saying any meaningful active phase till a month from now, so I don't know how much I believe that. So I'd say the takeaway from this from an MJO perspective is really no MJO support for storm development, no MJO forcing energy into the jet stream. It's just going to be whatever it's going to be, but there's no big help from the MJO. In fact, let's see, we can overlay the low-pass filter. Now, this tells a little bit of a different picture. The solid contour here, the low-pressure bias. This is your El Nino indicator, right? This would be rising air. And as of right now, the low-pressure bias is halfway across the Kelvin wave generation area. So really, it'd be nice if you did get some active phase married with this low-pressure bias. Good things could happen. But according to this, no real change in the low-pressure bias. According to the way it was last winter, low-pressure bias, this is in May, but it was even further to the east back last winter. So the low-pressure bias is more in the West Pacific this fall and this coming winter, according to this model, than what it was last year during a Madoki La Nina. And here is your high-pressure bias. I think there was 3 contours at one point, and it is off to the east a little bit more too. But we're still in some sort of a, from an MJO perspective, no MJO, and if anything, a bit of a La Nina pattern setting up. And we're going to get into that now. All right, so the title of the video, La Nina is in the ocean, but is it in the atmosphere? Well, let's start with the ocean and just prove that, in fact, La Nina is in the ocean. We're going to start by looking at subsurface water temperature anomalies. La Nina is defined by cooler than normal water in the east, warmer than normal water in the west. How would that happen? Well, if your trades are blowing stronger than normal, it would take all whatever the sun does to warm ocean temperatures in the East Pacific, like Equatorial East Pacific, like the Galapagos in that area, pushes it all to the west. So this is data from the TAO buoy array. Here are the anchor lines on the buoys. This is, again, two north to two south on the equator. So just a thin strip across the equator. But these little X's are sensors on the buoy lines. Take that in a model to fill in the gaps, and you can kind of get a profile of what the subsurface temperatures are doing. 29-degree isotherm at 173 east. I think that's what it was 2 weeks ago. The 24-degree isotherm at 175 west. That's pretty much where it was 2 weeks ago. And the 24-degree isotherm at 120 west, again, right about where it was. So no change, really. But it is not the actual water temperatures that matter. Again, it's the subsurface temperatures, or the anomalies. Compare the difference from normal. And this really paints the picture. You see warmer anomalies in the West Pacific, but 1, 2, 3 degree below normal temperatures from, where's the date line? The date line's way over here, so roughly here. Filling the whole Central and East Pacific. This new little, that's -1, so that's neutral. So all colder than normal temperatures over the entire East Pacific. That certainly looks like a La Nina pattern. And then we go, here's another version of this data. It uses satellite data in addition to the buoy data, but it's telling you the same thing. Colder than normal temperatures over the entire East Pacific. Well, there's the date line right there. So subsurface, there's this warm pool, but it's like hitting a brick wall about 165 west. So that'd be southwest of Hawaii, with cooler than normal temperatures over the entire upper ocean and subsurface. Again, this is very much some flavor of a La Nina pattern. Here's the satellite data. I know you can't quite read this, but this would be Central America here. That's the equator there. That's the date line there. Right there is the Galapagos. This would be Ecuador, and with Peru and Chile down here, and New Guinea over here. The positive values, these are not the oranges and yellows. That's not temperatures. That is the height of the ocean, the sphere of the ocean. You take a satellite, measure the ocean, take out all the wind waves, the tides, the actual swell, and is the sphere of the ocean higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contracts. When it contracts, it'll leave a divot on the ocean surface. Warm water at depth expands. It'll displace the ocean surface above it up some. So when you see this +5 centimeters, +10 centimeters, that means warm water here north of New Guinea, trying to reach the date line, but making zero headway because the trades are blowing harder than normal across here, holding all the warm water in a ball over here in the West Pacific, at the same time scraping out anything that might be, and creating upwelling here in the East and Central Pacific. This is a new development here. We had cold bulges up here and down here, but now they're starting to fill in over the equator. 10 centimeters below normal, 15 centimeters below normal, just confirming that there is a large mass of cooler than normal water here east of the date line. All that very consistent with La Nina. Upper ocean heat anomalies. This is pretty simple. This is the West Pacific here, East Pacific here, the blue colder normal water. This goes back a year. The red warmer than normal water. So last October, La Nina, cool water in the East Pacific, warm water in the West Pacific. That peaked out, and that was a late peak. It was like January and February. Then we got into April, May, and June. It almost looks like warm water flowing across the Pacific, but it wasn't. It was just a dampening of the trades that warmed up ocean temperatures some. But then we got into July 17th, I think it was, and then the trades started blowing again. We got the upwelling pattern, and here we are back to, well, how's this compare to last year at this time? Doesn't look as deep or as broad, but still some flavor of at least a La Nina-like pattern. pattern over the East Pacific. The subsurface temperature profile gives us sort of a hint of what's coming 3 months out because it takes a while for warm water at depth to work its way to the surface. But the ocean surface temperature anomalies are what really matter. If you have warmer than normal temperatures at the ocean surface, that supports evaporation. And if you get evaporation, you get clouds, and that sort of helps develop low pressure. If you have colder than normal water at the ocean surface, and I'm talking specifically on the equator, well, that doesn't support evaporation. It supports falling air, high pressure, and that is kind of a La Nina-like look. All right, so here is South America, Central America, New Guinea here. Here's the equator right there, date line right there. Looking at this, colder than normal temperatures over the Galapagos, the whole way across the Equatorial Pacific, building in coverage out here between the date line to about 120 west. This is the core of what they call the Nino 3.4 region, the official El Nino monitoring region. Nino 1.2 is right in here. Nino 3.4 out here, the official El Nino monitoring region. This clearly looks like some flavor of La Nina with colder than normal temperatures in control. Let's go look and see what's happened over the past 7 days. This is the sea surface temperature trend for the past 7 days. The good news is warming temperatures pretty much over the entire region. A little bit of cool out here south of Hawaii. A little bit of cool off of Ecuador, but nothing significant. Almost now these are just 7-day temperature changes. The trend, though, has been steadily cooler in this region. So if anything, I'd say maybe trades have backed off. In fact, we saw that in some of the previous charts. So it's allowing the sun to bake the ocean surface a little bit and warm up temperatures. But my guess is it's probably not going to be long-lived. Sea surface temperature anomaly. This is an alternate chart, just taking the average temperatures for the whole planet and then saying, okay, well, at any specific region, are you above or below what that normal is? This also paints the same clear La Nina signal, cooler water on the surface off of the Equatorial Pacific, filling the whole East Pacific. In fact, it even makes it look worse here than in the other charts. Sea surface temperature trend in the Nino 1.2 region there off the Galapagos and Ecuador. Temperatures almost approaching normal, 147 thousandths of a degree below normal. But you can see for almost a month now, there's probably been strong easterly anomalies. Temperatures have been 0.5 to 1 degree below normal. But the official El Nino monitoring region, that's really where the issue is. 811 thousandths of a degree below normal today. And for the past 1, 2, 3, 4 weeks, we've been at, let's say, roughly 3/4 of a degree below normal. El Nino or La Nina, well, let's try it this way. A neutral pattern is considered 0.5 degree below to 0.5 degree above. We are clearly below that. Now, you got to be below normal for like 5 consecutive months running. We're not there, but we've been in somewhere close to that 0.5 degree or below range since July, so July to August to September, so 2 months now. And this seems like the trend is clearly pushing colder. All right, so now we get even more to the root of what the video is about. What does the atmosphere think is going on? Subsurface ocean definitely looks cool. Ocean surface is cool and getting cooler. But has the atmosphere responded to that yet? Well, one way we can look at is the Southern Oscillation Index, the difference in pressure between Tahiti, which is in the Pacific, and Darwin, Australia, which is maritime continent. When pressure is lower in Tahiti, the index goes negative. When pressure is higher in Tahiti relative to Darwin, the index goes positive. Today, pretty much dead neutral, 0.12. What have we been doing the past month? It's kind of been toggling all over the place. We were at 15.9 a month ago. We're dead neutral now, so that kind of looks good. 30-day average, this takes some of the noise out, plus 5.24, which really isn't particularly high. Where were we a month ago? Dead neutral. So this suggests that on average, the pressure is rising. But that can be affected pretty mightily by the MJO, even though the MJO is extremely weak. And this 30-day number, if we were in a real, like a La Nina, this would be at least 10 or 12 and maybe 15 or more. So we're not there. 90-day average. The El Nino La Nina indicator, today 3.39. Where were we a month ago? 2.88. Really nothing. No big change. This would have to be up at like 10 before I'd say we're in some sort of a La Nina. Let's go look at a graph. Here's the 30-day running average of the SOI, the 30-day average. This, the Bureau of Meteorology in Australia says from +7 to -7 is neutral. Here we are today at +5. About as neutral as you can be, maybe just a little bit on the high side. And we've been, well, here's last winter's La Nina. We were up at 14 for a couple of spikes, but it was barely there. That was a Madoki La Nina. Right now, we're not even close to that. We're just in neutral territory. And then you can see there was a El Nino back here in 23, 24 kind of thing. And another atmospheric indicator, right? This is outgoing long wave radiation. This isn't the forecast. This is actual what's going on. The blues be cloudier than normal skies. That'd be the active phase of the MJO or wherever the low pressure bias is. And reds and oranges, clear skies, inactive phase, or La Nina. So here we were last winter with our La Nina. Oh, and that's the date line running right up the middle here. Here we are today, a little bit of cloud-free skies on the date line, cloudier skies in the far west Pacific. Wish they were pushing off to the east a little. If anything, it looks like the cloud-free skies are building in coverage some, but it's going to take another couple of weeks to this chart updates every 5 days. So for now, I'd say the model, the CFS model for the high and low pressure bias is probably pretty accurate, showing the low pressure bias 125 east is the entrance to the West Pacific. Low pressure likely in that area. High pressure over the date line, the dividing line about halfway in between. That's what the model's been saying. And that's what it seems like is happening. So here is the sea surface temperature anomaly forecast for the Nino 3.4 region, the official El Nino monitoring region. Again, half a degree below normal to half a degree above is considered neutral. This suggests that sometime here in the next week or two, temperatures are supposed to start dipping barely into La Nina territory, dropping to about 0.8 of a degree below normal in November, and then slowly rising from there. So if that's a La Nina, that's a pretty weak La Nina. And this is the more ungoverned or wilder version of the model. The PDF corrected reels it in a little bit and says 0.75 of a degree, 0.75 a degree below normal for November and December, and then rising pretty much back to neutral as you get to mid-January. So that really wouldn't qualify as a La Nina. And the consensus model updated just a day or so ago. Again, this shows half a degree above to half a degree below being neutral. All right. Let's see if I can pull this up here. The green is the statistic average. You can see it suggesting temperatures not even reaching into the La Nina threshold. The dynamic model right there is let's see, there's the red. You can see it's a little bit more aggressive. It says temperatures 0.71 of a degree, 0.66. In fact, let's go look at the table rather than dealing with the chart. All right, the dynamic models, all the models. Here's all the different models that forecast El Nino and La Nina. The average of all of them, 0.6, 0.7, 0.71 of a degree in roughly centered in November. Okay, and then rising from there. So that would be the weakest of weak La Nina conditions. The statistic model, not even that. It says temperatures going to 0.526, 0.5. That's not even La Nina. That's right on the border between between neutral and La Nina. So this suggests neutral bias cold, the statistic models. The dynamic models suggest just barely La Nina, but probably not for, what is this, 1 to a 3 month period? 4 months. Got to be 5 months to even qualify as La Nina. So probably not a La Nina. But there is one other indicator. Now we talk momentum for a little bit. This is what's actually happening, currents on the equator. There's South America there, Ecuador there, the Galapagos there. You can see this is an actual current of the water being driven by stronger than normal trade winds. And this takes momentum to get that kind of current blowing the whole way across the Pacific. And right there is like, well, let's see if we can get it. Oh, it won't pop up. It says 130 east. So the entire Pacific is dominated by this easterly current, and that's being driven by stronger than normal trade winds. So from a atmospheric perspective, it certainly looks like La Nina is already in control. So here's the rub. The CFS model, subsurface temperatures, okay? This is kind of hard to read, but the Pacific is between here and here, okay? And that is the date line right there, and that is warmer than normal temperatures. This is the forecast for October. So here's September. Here's what's actually happening. There's your cold water in the East Pacific, your warm water in the West. That's supposed to hold on October, November, December. Then magically by January, all that cold water erupts to the surface and warm water starts building into the West Pacific. Subsurface. The question is, do you believe that's really going to happen? Let's do one other. And here's your surface temperature chart. South America, Equatorial Pacific right there, dateline. There's your current cool pool, which really isn't that cool. This is actually the forecast for October. November, same thing. December, the cool water starts fading. By January, you're neutral and neutral on February and March, but you still sense that there's no warm water building there, that the trades are still maybe blowing stronger than normal, but just below the threshold for La Nina. And then the precipitation forecast anomalies. Reds would be drier air, greens wetter. So this is October. Seasonally, that'd be about right. November, notice precipitation confined north of the United States. You get into December, this is kind of an interesting pattern. Wetter in Southern California and dry all up in here. That's probably some sort of a monsoon flow. Then you get into January. The dividing line is Cape Mendocino. Sort of the same thing in February. Same thing in March. Really dry in California, according to this model. So for right now, well, a pretty weak surf pattern. At some point, just based on the seasons alone, the jet will drop further south. We'll get more, some sort of storm activity and surf activity, but as kind of expected, a late start to the season, the fall surf season, driven by a weak jet stream flow and no active phase of the MJO, and really just no momentum to like juice the swell production machine up. Looking longer term, some sort of a weak La Nina pattern is supposed to set up. Will it really be La Nina? I don't know. I mean, all the models and all the data sort of says, oh no, it's going to be like not much of a La Nina, if at all. But I look at the ocean current data, and that's actual ocean currents, and there's a lot of water moving. You're not just going to turn that thing off anytime soon. It'll take months of neutral to westerly anomalies blowing over the Pacific to shut that current down. And that current right now definitely is sort of not screaming, but strongly yelling, hey, La Nina is coming. Subsurface-wise, it all looks like La Nina. The model, the CFS model in particular, but all the other El Nino models are saying, oh yeah, but by, January, it's all going to be over. But kind of have my doubts. I think the models don't have a clue what's going on. I think the ocean is predisposed to La Nina. We were there all last winter. It was very weak, but I think we're in sort of the same thing. But the thing is, when you're in a second year of a La Nina pattern, it takes a lot more to sort of disrupt it and get some sort of a normal swell pattern going. And relative to rain into California, even more of a disruption will be required. Westerly anomalies will have to set up strong over the West Pacific to feed the jet stream and push it into California to get significant rainfall this winter. And at this point in time, I don't really see it happening. I was holding out hope, but I'm not anymore. Looking at the ocean current data, I just go, that's going to take 3 months of westerly anomalies to knock it down. And by the time that happens, even if something does happen in January to change the trade wind pattern, we'll be done with winter before the change sets in. So, kind of looks like La Nina long term. Short term, yeah, we're waiting for the change of seasons. Southern Hemi shutting down, North Pacific trying to come online, but just not really there. So my general suggestion is get whatever you can get surf-wise and make the most of it, and don't hold out for some bomb or swell, because I don't think it's coming anytime soon. That is our forecast for this week. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click down there in the lower right-hand corner of your screen, the Stormsurf icon. Get yourself all signed up. Comments, questions, always welcome. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with a $sign in it. With that, we are done for this week. We will do it again next week, same time, same channel. Thanks so much for watching.